Hello, my dear children, and welcome back. Oh, I am so happy to see you all here for another quick revision session. Today, we're going to master a really important chapter. And hey, if you find this useful, please share it with your friends. Let's help our little family grow, okay? Your support means everything to me.
Okay, let's dive right in. I have a question for you. You order some biryani on Zomato, right? And poof, in 30 minutes, the delivery person is right at your door. How? How on this massive, round Earth do they find your exact house? It's not magic, Beta, but trust me, it's just as cool.
The secret, my dears, is basically Earth's own Google Maps, an imaginary grid that covers the whole planet. Now, to draw a grid, you need two fixed points, 2 points that don't move at all. Think about a spinning top or a globe. What two spots stay in the same place? You got it, the North Pole and the South Pole.
So, using these 2 poles as our reference points, we can draw a whole network of lines all over the globe. And these lines have names, latitudes and longitudes. Together, they work just like the graph paper you use in maths class, giving a unique address to every single spot on Earth.
First up, let's talk about the horizontal lines. I have a silly trick to remember them. I call them the sleeping lines. Just remember, latitudes are Latitude lines. See? The ones that are lying down? These are officially called the parallels of latitude.
Now look at this picture from your book. See those lines going around the Earth? Latitudes are full circles that run east to west. And notice the most important thing. They are parallel. Just like railway tracks, they run alongside each other, but they never ever meet.
Okay, exam mode on. Quick, take a mental screenshot of this. So, latitudes run east-west. They are full circles, and they're parallel. The big boss of all these lines is the equator, right in the middle at 0 degrees. And as you go up towards the North Pole or down to the South Pole, see how the circles get smaller and smaller? And fun fact, the distance between each degree line is about 111 kilometers.
So we've got the sleeping lines down. Now what about the standing lines? You guessed it, these vertical lines are called the meridians of longitude.
And here they are. Look at how different they are from latitudes. They all run from the North Pole all the way down to the South Pole. So they aren't full circles, are they? No, they are semicircles. Think of an orange. They're just like the slices of an orange, all meeting at the top and the bottom.
More important points for your notes, my dears. Longitudes run north-south. They're semicircles. And yes, they all meet at the poles. And unlike latitudes, which get smaller, all longitudes are the exact same length. Their main line is called the prime meridian, which is at 0 degrees. And you can see they are furthest apart at the equator, and then they get closer and closer till they touch at the poles.
Now, listen very carefully. This slide, this is a PACA 3-mark question. I can almost guarantee you'll see distinguish between latitudes and longitudes in your exam. So let's revise. Latitudes are full circles. Longitudes are semicircles. Latitudes are parallel. Longitudes meet at the poles. Latitudes are unequal in length. Longitudes are all equal. And most importantly, their main job is different. Latitudes help us figure out heat zones, but longitudes have a secret superpower.
All right, this is my favorite part. Latitudes are great for climate, sure, but longitudes have this amazing secret power that we use every single second of our lives. Any guesses what it is?
That's right, time. The time on your phone right now. The time school starts. It's all because of longitude. Isn't that amazing? Let me show you how it works.
So we all know the Earth spins one full circle, which is 360 degrees, in about 24 hours. Now, if you just do a little bit of simple math, 360 degrees divided by 24 hours, it means the Earth moves 15 degrees every hour. And if we break that down even more, it means for every 1 degree of longitude, 4 minutes of time passes. This, my children, is the golden rule. Write it down. 1 degree equals 4 minutes. Just remember this.
And because of this rule, we have this, the World Time Zone Map. Each of these colored bands is a different time zone. This is why when it's daytime here in India, it's nighttime for your cousin living in America. It's all because of longitude and that simple 4-minute rule.
Now I know what you're thinking. Oh no, a math problem in geography? But don't you worry at all. These are actually super simple once you know the trick. We're going to solve one together, step by step. Come on.
Here's our question, a classic one from your textbook. We need to find the time in Thimphu, which is at 90 degrees east, at the exact moment when it is 12 o'clock noon in Greenwich, which is at 0 degrees longitude.
Let's break it down. Step 1.
What's the difference in longitude? Well, Thimphu is at 90 east, Greenwich is at 0, so the difference is just 90 degrees. Easy. Step 2. Now we use our golden rule. 1 degree is 4 minutes, so 90 degrees will be 90 times 4, which is 360 minutes. Step 3. Let's turn those minutes into hours. 360 minutes divided by 60 minutes in an hour gives us 6 hours. Perfect. And the final step. Since Thimphu is to the east of Greenwich, the sun gets there earlier, so we add the time. 12 noon plus 6 hours is 6 p.m. See, I told you it was easy.
Excellent job, everyone. It's all about that one simple rule, isn't it? Now that you know how to calculate time for any place on Earth, let's look at one last super important point for your exams, our very own Indian Standard Time.
You see, India is a very wide country, so to make sure the time is the same for everyone, whether you're in Gujarat or Arunachal Pradesh, we picked one longitude line that passes through the middle of the country. That line is 82 degrees and 30 minutes east. Now, let's do our calculation. 82.5 degrees times 4 minutes, that's 330 minutes. And 330 minutes is exactly 5 hours and 30 minutes. And because we are east of Greenwich, we are ahead. That's the story of why IST is always 5.5 hours ahead of London time.
So to make sure you've really got this, here's a little homework for you. We just did the calculation, but I want you to tell me the answer in your own words. Pop your answer in the comments below. I want to see everyone getting this right, okay? I'll be checking every single one of your comments. Thank you for studying with me today, Beta. You're all doing great. I'll see you in the next one. Bye-bye.